So good afternoon all of you. Today we will be learning the topic electricity and which is of class 10th standard. Okay. So before starting the electricity, what is current? We need to know what is current. If something is flowing, we can say that it is current. If air is flowing, we may call it as an air current. If water is flowing, we will be calling it as a water current. So what flows? So we can say that it is electric current. So if charge flows, if charge flows, we can say that it is electric current. It is electric current. Now, if the charge flows, we can say that it is electric current. Now, talking about the charge, what kind of charges are? So there are two types of charges. Talking about the different type of charges are the positive charge and the negative charge. The positive one and the negative one. So there are two types of charges, the positive as well as negative. Now, in an atom, there are subatomic particles which are electrons, protons and neutrons. Now, talking about the electrons, electrons carry the negative charges. So negative charges are carried by the electrons and the protons carry the positive charge. So positive charge is carried by the protons. Now, talking about the magnitude of both the charges, the magnitude of both the charges that is electrons and protons remains same. So what is the difference? The difference is only the polarity of these two charges. The electrons carry the charge in negative in nature and the protons carry the same charge in positive in nature. Now the question arises over here that whether electron moves or proton moves, which kind of charges moves to constitute electric current. So let us have a look. Suppose I am having an atom over here. Okay, and this atom, the centralmost part is called the nucleus. It is called as the nucleus, and these outermost are called as shells. These are called as shells. The protons, the positive charge, and the neutrons, which are basically neutral in nature, these two types, protons and neutrons, lies inside the nucleus. The protons and neutrons lies inside the nucleus. So the positive charges are bound inside the nucleus. They are bound in nucleus. Now talking about the negative charge are present in the cells. The negative charge, that is the electrons, are present in cells. They revolve around the nucleus. They generally revolve around the nucleus. So electrons are in shells. They are in shells and they are free to revolve. They are free to revolve. Free to revolve. So what kind of charges can flow? Will it be positive or will it be negative? So as we know that the positive charges are bound into the nucleus, so they cannot move, but yes, the negative charges are in the shells. They are free to revolve. So these charges will only be flowing and constituting an electric current. So what kind of charges flow? The negative charges, that is electrons flow. Or whenever we are talking about that the charges are transferred from one object to the other, we will always be saying that yes, the electrons are getting transferred from one object to the other. We will never be saying that protons is getting transferred from one object to the other. What we will be saying? We will be saying that the negative charge, that is electrons, are getting transferred from one object to the other object. Now, how can we define electric current? So, talking about the definition of the electric current, the electric current can be defined as the rate of flow of charge. The electric current can be defined as the rate of flow of charge through any cross section of the conductor. The rate of flow of charge through any cross section of the conductor. Now, whenever I am talking about the rate of, it means 1 by t. And if I'm talking about the charge is represented by Q. So what will be the rate of flow of charge? It means that 1 by T, rate of into flow of charge. And this is called as current. So current is denoted by I. So here we have the relation between I, Q and T. That is I is equal to Q by T. So from here we can say that the rate of flow of charge through any cross section of conductor, please, through any cross section of conductor, then yes, we can say that it is an electric current. Now, talking about the units of the charges, time and the current, the SI unit, that is standard international unit of the charge, is coulomb. It is coulomb, which is denoted by capital C. And the unit of time, as we know, that it is seconds, which is denoted by small s. And here the unit of current will become as coulomb per second. Now, what is this coulomb per second called as? It is also called as ampere. It is also called as ampere. So the SI unit of current is ampere. And now what is ampere? The ampere is coulomb per second. Now the second thing arises over here, that how can we define 1 coulomb? Sorry, how can we define 1 ampere? Now, if we have to define 1 ampere, we can say that 1 ampere can be 1 coulomb per 1 second. 1 ampere can be defined as 1 coulomb per 1 second. So how can we define it? We can define it in the way that if 1 coulomb of charge flows through any cross section of conductor in 1 second. In 1 second. If 1 coulomb of charge is flowing through any cross section of conductor in 1 second, then we can say that the current flowing through that conductor is 1 ampere. So it will be the definition of 1 ampere. That the 1 ampere is defined as 1 coulomb per 1 second. Now, talking about the other thing is that suppose we are having a conductor over here. We are having a conductor over here. So as it is conductor, the conductors have free electrons inside them. The conductors have free electrons inside them. So electrons will be present inside the conductor. And as we know that the electrons are free to revolve, so yes, these electrons will be moving in a random direction. We don't know, but yeah, the electrons will be moving in a random direction. So if the electrons are flowing in a particular conductor, so while flowing, they will be constituting an electric current. So whenever we are touching a conductor, why don't we feel that current? Whenever we are touching a conductor in which electrons are flowing and it is constituting an electric current, so why we don't feel that electric current? The reason over here is that whenever we are taking any cross section of the conductor, the average number of flow of electron is 0. The average number of flow of electrons is 0. What does it mean? It means if I am taking the cross section AB, and if one electron is going to the right side, the one electron might be coming to the left side. It means the flow of this electron will be constituting an electric current, suppose I1, and this electron will also constitute an electric current, suppose I2. As both the charges are same, this I1 should be equal to I2, and the movement of both the electrons are opposite, so the movement of or direction of current will also be opposite. We will be discussing the direction of the current later on, but yeah, they both will be constituting an electric current opposite in direction, so they both will nullify each other's effect. So that's why we don't feel the effect of current. Now coming upon the direction of current, suppose I am just connecting this conductor with a battery. Suppose I am connecting this conductor with a battery whose potential difference is V. Suppose I am conducting this conductor with a battery whose potential difference is V. Now, here is a switch. This is a switch. A switch is represented in this way, and this is a battery. Suppose the potential difference of battery is V. The potential difference of battery is V. We will be discussing what the potential difference is. But currently, we want to know the direction of current. Now, if we have applied a potential difference across this conductor, the longer terminal is represented as the positive terminal and the shorter terminal is represented as the negative terminal. The positive terminal of the battery is always considered to be higher potential. It is always considered to be higher potential. And talking about the negative terminal, it is always considered to be as the lower potential of the battery. It is always considered to be as the lower potential of the battery. Now, if the conductor is connected with a potential difference of a battery, suppose the potential difference is V, so now these electrons which are negative in nature will get attracted towards the positive charge, as we know that the unlike charges attract each other. So yes, these electrons will now start moving in a particular direction. These all electrons now will start moving in a particular direction, and all these electrons will get attracted towards the positive terminal of the battery, and they will start drifting towards the positive terminal of the battery. Now why they are drifting? Because now also these electrons will facing some type of collisions, and yes, they will be losing their energy also, but they will be drifting towards the positive terminal. And due to their movement towards the positive terminal, since all these electrons are moving in a particular direction, so now if we will be considering any cross section of a conductor, the net number of electrons will not be zero. And now if we will be touching this conductor, we will basically feel the electric shock or the electric current. Now, discussing on the direction of electric current, the electrons always moves towards positive terminal. And if the electrons are moving towards the positive terminal and they are constituting an electric current, so an electronic current will be formed in the same direction. The electronic current, what I am saying, the electronic current will be formed in the same direction of the electrons. But now here comes a word, conventional. What is conventional current? We have assumed that our current will be always in the opposite direction of flow of electron. We have assumed that our conventional current will always be in the opposite direction of flow of electron. It means that the conventional direction of current will be from positive terminal to negative terminal. This is the direction of conventional current. So the electrons move from negative terminal to the positive terminal because the electrons will be repelled by this negative terminal and attracted towards the positive terminal. And if the electrons are coming towards the positive terminal, the current flow is always opposite to the direction of electron. So conventional current will always move from positive terminal to the negative terminal. Now what does it mean? It means that we can say that current always flows from higher potential to lower potential. Current always flows from higher potential to lower potential because the positive terminal was considered as higher potential, the negative terminal was considered as lower potential. So we can say that current always travels from higher potential to lower potential. We can write it down, higher potential as HP and lower potential as LP. So current always travels from higher potential to lower potential. Now talking about the current is what kind of quantity? Is current a scalar quantity or a vector quantity? Before discussing the type of quantity, we have to discuss something, and that is, if I'm talking about current, suppose the current is denoted by I, and now I'm saying, suppose 5 ampere of current is flowing through any cross section of the conductor. Now what does this 5 indicates? This 5 indicates the magnitude of current. It indicates magnitude of current. What does this ampere indicates? It indicates unit of current. It indicates unit of current. Now, what kind of physical quantity the current is? Is this a scalar quantity or a vector quantity? So, the current has a magnitude. Yes, it has a magnitude. And just now, we have seen that it has a direction also. It has a direction also. But the current has magnitude also and direction also. Due to these two conditions, most of the people think that the current is vector quantity. But no, the current is not a vector quantity. Why is it so? Because there are 3 requisite conditions to be a vector quantity. And those are, it should have magnitude, it should have direction, and it should follow vector law of addition. The current does not follow vector law of addition. The current does not follows vector law of addition. Vector law of addition. And since the current does not follows the vector law of addition, it only has magnitude and direction. So we can say that the current is scalar quantity. The current is a scalar quantity and not the vector quantity. So what we have learned today, let us summarize. It was, what does electricity means? So the flow of charge is called as electric current. What kind of charge? The negative charges flow. So the flow of negative charge per unit time through any cross section of conductor is said to be electric current. Now, other than this, we can define that the relation between I, Q and T was I is equal to Q by T. The SI unit of Q was coulomb, the SI unit of time was second, and the SI unit of current was coulomb per second, which is also called as ampere. Coming upon over here, why we don't feel electric shock when the conductor is not connected to a battery. So the reason is that there is a flow of electron, but whenever we will be considering any cross section of the conductor, the net flow of the number of electrons will always be 0. That is why we don't feel electric shock whenever the conductors are not connected to any of the potential difference. But yes, when we develop a potential difference across this conductor, we feel that electric current. Why is it so? Because the electrons start flowing in a particular direction due to the positive and negative terminal that is higher and lower potential of the battery. The electrons always moves towards the positive terminal. So our conventional current will move opposite to the direction of flow of electron. So conventional current will move from positive terminal to the negative terminal. So yes, we can say that current travels from higher potential to the lower potential. We can also say that the positive charges, if we want to say, we can say that positive charges also move from higher potential to lower potential, because the electrons were traveling from lower potential to higher potential. So yes, the opposite one, the positive charges, will be moving from higher potential to lower potential. And yes, the current was having a magnitude and direction, but it does not follow the vector law of addition. So it is not a vector quantity. So yes, the current is scalar quantity. And that's it for the day. Thank you.